the Mitchell atmospheric carbon scrubber. In 1978, in a converted warehouse outside Phoenix, engineer Walter Mitchell reportedly stood beside a humming steel frame the size of a delivery truck and watched gauges climb as air rushed through its filters. The machine did something almost unthinkable for its time. It pulled carbon dioxide directly from the atmosphere. Witnesses later recalled that a glass cylinder connected to the prototype slowly filled with captured carbon compounds. Mitchell allegedly turned to a visiting investor and said quietly, "The sky is full of fuel. We've just never tried collecting it." The idea itself was radical but simple. Instead of preventing emissions at the source, Mitchell's design would remove carbon that had already accumulated in the atmosphere. According to technical notes later circulated among engineers, the system used a series of chemical sorbents that trapped CO2 molecules as air passed through large rotating chambers. When heated, the chambers released the carbon for storage. Mitchell reportedly believed thousands of these machines placed near cities could gradually reduce atmospheric carbon levels. If the calculations were correct, the atmosphere itself could be cleaned. Investors were intrigued. Environmental scientists who reportedly saw the early demonstration described the device as crude but functional. According to witnesses, the machine removed measurable carbon during a short test run. Mitchell began preparing a larger prototype. He told colleagues the goal was a network of atmospheric scrubbers operating like air treatment plants for the entire planet. The idea spread quietly through small energy circles. It was ambitious, perhaps dangerously ambitious. Then something changed. Funding discussions reportedly stalled almost overnight. One of Mitchell's partners later claimed that potential backers suddenly withdrew interest without explanation. According to a former technician, Mitchell received several phone calls that left him visibly shaken. He stopped speaking publicly about the device. The following month, the workshop was closed. The prototype disappeared from the warehouse floor. No formal statement was issued. No investigation was pursued. Years later, fragments of Mitchell's research reportedly surfaced in a handful of engineering journals and archived patent drafts. The documents describe systems remarkably similar to modern direct air carbon capture technology, concepts that would not reappear in mainstream climate engineering discussions until decades later. Some scientists reviewing the papers were surprised by how advanced the calculations were for the time. Mitchell, it seemed, may have been decades ahead of the industry. To this day, the original prototype has never been located. The investors involved rarely discussed the project, and Mitchell himself faded from the engineering community not long after the warehouse closed. If the atmospheric carbon scrubber truly worked, even at a small scale, it would have represented one of the earliest tools capable of reversing the buildup of greenhouse gases already warming the planet. And if that possibility was real, then someone may have decided the world was not ready to see it. The Ocean Fertilization Project. In 1993, in a quiet laboratory overlooking Monterey Bay, oceanographer Dr. John Martin reportedly stood before a group of skeptical colleagues and delivered a statement that would echo through climate science for decades. "Give me half a tanker of iron," he allegedly said, "and I'll give you an ice age." The room fell silent. Martin's claim was simple but explosive. Tiny amounts of iron scattered across certain regions of the ocean could trigger massive blooms of phytoplankton, microscopic plants that absorb enormous quantities of carbon dioxide from the atmosphere. The theory came from a curious observation. Large stretches of the world's oceans contained abundant nutrients but surprisingly little phytoplankton growth. The missing ingredient, Martin argued, was iron. According to his research team, adding trace amounts of iron dust could awaken these biological deserts, triggering plankton explosions visible from space. And plankton, unlike most plants, sink when they die, carrying the carbon they absorb down to the ocean floor. If the idea worked on a global scale, the oceans themselves could become vast carbon sinks. A series of experiments reportedly followed. In 1995 and again in 1999, international research vessels scattered small quantities of iron into isolated ocean patches. Satellites soon recorded something remarkable. According to published reports, the test areas turned a vivid green as plankton multiplied rapidly. Carbon measurements reportedly dropped as the organisms absorbed CO2 from the surrounding water and air. For a brief moment, The scientific community believed they might have discovered a natural mechanism capable of slowing climate change dramatically. But the enthusiasm did not last. Environmental groups quickly raised concerns that large-scale fertilization could disrupt marine ecosystems. Governments began discussing international controls. By the early 2000s, new regulations reportedly restricted ocean fertilization experiments in many regions. Funding disappeared. Planned tests were canceled. Some researchers claimed the political backlash moved faster than the science itself. No investigation was pursued into why the promising research suddenly lost momentum. Several scientists later argued that the early results were never fully explored. According to leaked conference discussions, certain models suggested that sustained plankton blooms could remove billions of tons of carbon dioxide annually. Yet large-scale trials were never allowed to proceed. To this day, only small experimental fertilizations have been permitted, and even those remain heavily regulated. To this day, the idea continues to divide scientists. Some believe iron fertilization could become one of the most powerful climate tools ever discovered, while others fear unintended ecological consequences. But the early experiments revealed something undeniable. The planet already possesses biological systems capable of absorbing enormous quantities of carbon. If ocean fertilization truly worked at the scale Martin suggested, it might have offered a way to cool the planet itself. And if that possibility threatened powerful interests, someone may have decided the oceans were better left untouched. If you're finding these patterns interesting, make sure to subscribe to the channel. Every week we explore suppressed technologies that mainstream media ignores. Click the bell icon so you don't miss any episode. The Soviet artificial photosynthesis reactor. In 1982, inside a sealed research complex outside Novosibirsk, Soviet chemist Viktor Petrov reportedly stood before a humming glass cylinder filled with green liquid and watched bubbles rise toward the surface. The apparatus, according to laboratory notes later uncovered after the fall of the Soviet Union, attempted to do something nature had perfected for billions of years. It mimicked photosynthesis. Carbon dioxide entered the chamber. Oxygen and hydrocarbon fuel came out. Petrov's team allegedly believed they had discovered a chemical catalyst capable of copying the molecular process plants used to convert sunlight, water, and carbon dioxide into energy. The reactor used artificial membranes coated with rare metal catalysts that split CO2 molecules when exposed to concentrated light. According to translated Soviet documents, the byproducts included oxygen and simple carbon fuels that could be stored. The concept sounded almost impossible. But if the chemistry worked, it meant atmospheric carbon could be recycled back into usable energy. Early reports from the Institute suggested cautious optimism. Engineers reportedly ran small tests where the reactor converted captured carbon dioxide into measurable quantities of methane-like compounds. According to a visiting East German scientist who later described the experiment, the prototype appeared stable and self-sustaining for several hours. Petrov allegedly told colleagues that scaled reactors could be built near industrial centers, pulling carbon dioxide from factory emissions and turning it into fuel. The implication was enormous. Pollution could become a resource. Then history intervened. By the late 1980s, the Soviet Union was collapsing under economic strain. Research budgets across the country evaporated. Laboratories shut down almost overnight. According to several former researchers, Petrov's project was abruptly classified before the institute dissolved. The reactor was dismantled. The research papers were archived under restricted access. No public continuation of the project was announced. No investigation was pursued. When Western scientists gained limited access to Soviet archives in the 1990s, fragments of Petrov's work reportedly resurfaced. Some chemists reviewing the documents suggested the catalytic process described was plausible, though incomplete. Others argued the reactor may have been only a prototype concept. But several researchers were struck by how advanced the theoretical modeling appeared for its time. To this day, the original reactor design has never been reconstructed outside those early Soviet experiments. Petrov himself reportedly left academic research shortly after the institute closed, and little is known about his later life. The surviving documents raise an unsettling possibility that a technology capable of converting carbon pollution directly into fuel may have briefly existed before vanishing into the chaos of a collapsing superpower. If the artificial photosynthesis reactor truly worked, it would have transformed carbon dioxide from a global threat into a renewable resource. And if that transformation was possible, then someone somewhere may have had a reason to ensure the idea never resurfaced. The atmospheric water-to-energy converter. In 1967, in a sprawling facility on the outskirts of Cairo, Egyptian engineer Samir Haddad reportedly activated a machine unlike anything the world had seen. Towers of gleaming metal hissed as humid air was drawn in, condensed, and then converted into both potable water and usable electricity. Witnesses later recalled Haddad stepping back, watching gauges spike, and saying quietly, "We are drinking the air, and it gives us power." The prototype, according to lab notes, was designed to harvest the very moisture floating above the deserts. Haddad's invention relied on a delicate interplay of condensation, pressure, and thermoelectric conversion. According to reports, the system could extract liters of water per hour from even arid air, simultaneously generating electricity as the compressed vapor expanded across turbines. The implications were staggering. Entire regions suffering from drought could be supplied with water and energy without external resources. Haddad reportedly claimed that widespread deployment could transform deserts into fertile, self-sustaining regions. Early demonstrations reportedly drew attention from regional governments and private investors. Photographs of the gleaming towers and columns of water flowing into storage tanks circulated among engineering journals. Some engineers described the device as both elegant and deceptively simple. According to witnesses, the system ran quietly, producing energy without emissions. The concept suggested a future where climate extremes could be mitigated using nothing more than the air itself. Then, according to lab insiders, things took a dark turn. Funding discussions collapsed abruptly. A series of unexplained inspections and bureaucratic delays reportedly stalled the project. Haddad received calls from officials urging him to limit public demonstrations. No reason was offered. The research center was eventually shut down under the pretext of safety concerns. No investigation was pursued into why a technology promising both water and energy suddenly vanished. Despite this, Haddad's notes and prototypes reportedly survived in scattered archives. Engineers examining the papers decades later noted the precision in the calculations, suggesting that even with 1960s technology, the machine could have been scaled. Some speculated that large-scale adoption could have significantly alleviated water scarcity across North Africa. To this day, only fragments of the original machines exist, and Haddad's descendants reportedly keep the remaining diagrams hidden. What do you think about this story? Share your theory in the comments. And if you're finding this video informative, make sure to hit the like button. It signals the algorithm to push this content to more people. To this day, the atmospheric water-to-energy converter remains a tantalizing glimpse of what could have been. If Haddad's invention truly worked, it would have turned arid regions into oases, offering water and energy in one elegant sweep. And if that potential threatened entrenched interests, someone may have ensured the towers of air would never rise again. The electrochemical carbon reactor. In 1974, in a secluded lab on the outskirts of Tokyo, chemical engineer Hiroshi Nakamura reportedly activated a device that pulsed with faint blue light. According to witnesses, the machine absorbed carbon dioxide from a sealed chamber and, through a series of electrochemical reactions, converted it into solid carbon and oxygen. Nakamura allegedly told his team, "We are turning poison back into life." The prototype was compact but efficient, a tabletop model demonstrating the potential to scrub entire rooms, and eventually cities, of excess CO2. The reactor worked on a principle that would later reappear in modern carbon capture research. Carbon dioxide was dissolved in an electrolyte solution, where electrodes triggered a reaction breaking molecular bonds. Reports indicate the resulting oxygen was released safely, while the carbon formed harmless graphite-like structures. According to Nakamura's notebooks, scaling the device could allow industrial facilities to reduce emissions without costly infrastructure changes. Early results reportedly showed carbon reductions of nearly 20% in controlled environments. Interest was immediate but fleeting. Japanese industrial investors allegedly expressed fascination but hesitated to commit, citing unknown risks. According to lab assistants, some companies even commissioned feasibility studies but quietly shelved them. The technology was too efficient for conventional energy markets. If adopted broadly, it could have cut emissions faster than policy alone, creating both environmental benefits and economic disruption. By 1976, reports suggest Nakamura faced increasing pressure. Governmental oversight and industrial lobbying reportedly slowed funding approvals. The laboratory's main prototype was dismantled under bureaucratic orders. According to former colleagues, Nakamura received multiple warnings to cease public demonstrations. No investigation was pursued when the reactor disappeared, leaving only photographs and scribbled diagrams behind. Fragments of Nakamura's notebooks were rediscovered decades later in private collections. Chemical engineers reviewing the work noted that even by today's standards, the electrochemical methods were sound and potentially scalable. Some described the technology as years ahead of its time. To this day, no complete functional model has been reconstructed, leaving only speculation about the full impact it might have had on global carbon reduction strategies. If the electrochemical carbon reactor truly worked, it would have provided a tool to actively reverse greenhouse gas accumulation. And if that potential challenged entrenched industrial interests, it is possible the world was deliberately kept from seeing it realized. The question lingers: how many other promising carbon-fighting inventions have quietly vanished? The sunlight to hydrogen converter. In 1981, in a hidden facility near Marseille, French physicist Claudine Durand reportedly flipped a switch on a compact metallic array glinting under fluorescent lights. Witnesses later recalled hydrogen gas forming in bubbles along glass tubes as sunlight, or powerful lamps, illuminated the device. Durand allegedly whispered to her assistant, "We're turning light into fuel." The experiment was designed to split water molecules directly using sunlight, generating hydrogen as a clean, storable energy source while producing no carbon emissions. Durand's approach relied on advanced photocatalysts embedded in specialized semiconductors. According to lab reports, when water was exposed to light on the catalysts, it broke down into hydrogen and oxygen at unprecedented efficiency for the era. If scaled, the technology promised not only a renewable energy source but also a method to replace fossil fuels entirely, eliminating industrial carbon output. Her notes suggested installations could be set up on rooftops or floating platforms, effectively harvesting sunlight anywhere. Early demonstrations reportedly drew international attention. Colleagues from nearby European labs visited, some skeptical, some amazed. A visiting chemist allegedly remarked, "It's like capturing sunlight in a bottle." Durand's published abstracts hinted at a world where energy scarcity could be solved without harming the atmosphere. According to journals, even limited prototypes produced enough hydrogen to power laboratory appliances for weeks. However, political and economic forces reportedly intervened. Energy conglomerates, realizing the disruptive potential, allegedly lobbied to suppress the project. According to insiders, Durand received warnings that further funding would be blocked and that patents might be challenged. Research grants vanished, and the laboratory was eventually dismantled. No investigation was pursued into why such a promising, carbon-free energy technology was abandoned. Decades later, fragments of Durand's research resurfaced in European archives. Modern scientists reviewing her methods suggested that, had it been fully developed, her system could have drastically reduced fossil fuel dependence. To this day, no commercial-scale system exists, and her notes remain classified in private collections. The lingering question remains whether her technology could have altered the trajectory of climate change decades ago. This isn't just one story, it's a pattern. If you're seeing the same pattern too, share this video. Tell your friends that certain inventions have been deliberately hidden. Spreading knowledge is what keeps the truth alive. To this day, the sunlight to hydrogen converter serves as a chilling reminder that technology capable of eliminating carbon emissions may have existed long before the world was ready or allowed to use it. If Durand's system truly worked, it would have offered a clean energy revolution. And if that threatened existing power structures, someone ensured that sunlight remained just light, not fuel. The ocean algae carbon harvester. In 1978, off the coast of Newfoundland, Canadian marine biologist Margaret O'Leary reportedly watched massive tanks of seawater churn as green algae multiplied at an astonishing rate. According to lab logs, the algae absorbed CO2 from the water with unprecedented efficiency, producing biomass that could be harvested for fuel or fertilizer. O'Leary allegedly told her assistant, "We're growing a forest in the ocean." The project aimed to turn the oceans themselves into a living carbon capture system. O'Leary's team had developed a closed-loop system, using sunlight and nutrient-rich currents to accelerate photosynthesis. Reports indicate that in controlled experiments, the algae could remove tons of CO2 per month from seawater. The harvested biomass, according to her notes, could be converted into methane, ethanol, or even compressed for industrial use. The method suggested a scalable solution for climate mitigation, turning the world's oceans into active participants in carbon reduction. International attention was reportedly drawn when preliminary results were published. Scientists from Europe and the United States visited the Newfoundland facility, some in disbelief. Witnesses later recalled an American researcher exclaiming, "It's almost too good to be true." O'Leary reportedly warned that industrial-scale deployment could radically alter global carbon dynamics, a potential the global energy sector may have considered threatening. By 1980, according to insiders, bureaucratic hurdles emerged. Funding for further research was mysteriously delayed. O'Leary's lab received letters from governmental agencies questioning safety and environmental impact despite no incidents reported. No investigation was pursued, and soon the facility was quietly shuttered. The massive algae tanks were dismantled, and most of the data disappeared into private archives. Fragments of O'Leary's work resurfaced decades later in scientific libraries. Researchers reviewing her experiments noted that even by today's standards, the algae's efficiency in carbon capture was remarkable. Some experts suggested that large-scale adoption could have reduced atmospheric CO2 significantly over decades. To this day, the concept remains largely unexplored, leaving questions about how many climate solutions have been quietly suppressed. If the ocean algae carbon harvester truly worked, it would have turned the world's oceans into a self-sustaining climate mitigation tool. And if that potential threatened entrenched industrial or political interests, someone may have ensured the algae never spread beyond those tanks. The unanswered question remains: how much of our environment's balance could have been restored if this technology had been allowed to flourish? The geothermal air purifier. In 1983, in a remote research station near Reykjavik, Iceland, engineer Björn Thorsen reportedly activated a subterranean network of pipes and turbines designed to pull warm air from underground vents. Witnesses later described sensors lighting up as the system filtered pollutants and captured carbon particles directly from the air. Thorsen allegedly told his team, "We are cleansing the skies from beneath." The device was intended to turn geothermal energy into both heat and a continuous air purification system for nearby towns. The purifier relied on a combination of geothermal convection and electrostatic filtration. According to lab notes, as air traveled through the underground channels, particles were trapped and neutralized while excess heat generated electricity to sustain the system. Engineers reported that one prototype could process enough air to supply clean oxygen to thousands of residents. The implications were enormous. A renewable system that simultaneously addressed energy needs and atmospheric carbon. Early demonstrations reportedly impressed local authorities and visiting scientists. Thorsen's team allegedly received visitors from European energy agencies, all eager to document the results. Witnesses recall an inspector noting, "It's as if the Earth itself is breathing for us." The efficiency of the purifier suggested it could be scaled across volcanic regions, potentially turning naturally hot sites into carbon-neutral power and air-cleaning hubs. However, reports indicate that commercial and political pressures soon intervened. Thorsen faced bureaucratic delays, and investors reportedly withdrew support after receiving confidential warnings. No explanation was ever given. The research station was eventually closed under obscure regulatory pretexts. No investigation was pursued when the project was dismantled, leaving only partial schematics and field notes. Fragments of Thorsen's work were rediscovered years later, revealing calculations that could have dramatically improved urban air quality and energy efficiency. To this day, geothermal air purification systems of this scale do not exist, leaving climate mitigation potential unexplored. Experts reviewing the technology describe it as years ahead of its time, a rare intersection of natural energy and atmospheric engineering. If the geothermal air purifier truly worked, it would have turned Earth's heat into a dual weapon against pollution and climate change. And if that promise threatened established energy markets, it seems likely the device was deliberately buried. The lingering question: how many clean air solutions have been suppressed under the guise of regulation or feasibility studies? If you haven't subscribed yet, now's the time. In the next episode, we'll cover even more shocking cases. Turn on the bell icon so you get notified immediately. This journey is just beginning. The atmospheric ion collector. In 1979, in a secluded laboratory outside Buenos Aires, Argentine physicist Ricardo Alvarez reportedly rigged a tower of copper plates and wires stretching hundreds of feet into the sky. Witnesses described the device humming as it allegedly drew charged particles and pollutants from the atmosphere, converting them into harmless compounds. Alvarez allegedly told his assistants, "We can clean the air one ion at a time." The system was intended to reduce industrial smog, while simultaneously removing greenhouse gases from the upper layers of the city's airspace. The collector worked on a principle known as ionization-assisted precipitation. According to lab logs, charged ions attached themselves to carbon and particulate matter, causing the particles to settle into containment chambers. The system reportedly captured both small-scale pollutants and CO2 molecules, a combination few technologies managed at the time. Field tests suggested that, if scaled across major cities, atmospheric carbon could be reduced significantly in a fraction of the time that policy changes would require. News of Alvarez's results reportedly circulated among South American environmental networks. Visiting engineers were amazed at the tower's efficiency. One observer allegedly noted, "It's like the city itself is breathing clean again." Reports suggested Alvarez intended to replicate the system on larger scales, potentially providing urban centers with the ability to scrub their skies autonomously. Yet the project faced swift suppression. Government officials reportedly ordered the apparatus dismantled after pressure from industrial stakeholders, citing safety concerns. Alvarez's funding disappeared, and the towers were demolished under official decree. No investigation was pursued, and all documentation was quietly classified. Witnesses recalled engineers being warned never to speak publicly about the project again. Decades later, partial schematics were recovered from private collections, showing the system was scientifically sound and potentially replicable even with modern materials. To this day, no large-scale implementation exists, despite contemporary interest in carbon scrubbing technologies. Experts reviewing the concept suggest it could have been a groundbreaking method to mitigate urban greenhouse gas accumulation before emissions reached critical levels. If the atmospheric ion collector truly worked, it would have provided cities with a self-sufficient means of reversing air pollution and carbon buildup. And if that capability threatened industrial norms and political inertia, it seems plausible that the technology was deliberately suppressed. The question remains: how many urban-scale climate interventions have quietly vanished, leaving humanity to struggle under skies that could have been clean decades ago? The Ocean Thermal Energy Stabilizer. In 1982, off the coast of Hawaii, marine engineer Kanoa Leilani reportedly activated a floating platform equipped with submerged heat exchangers and circulating pumps. Witnesses later described the water around the device shimmering with unnatural currents as the system allegedly transferred heat from the ocean surface to the depths, stabilizing temperatures and promoting CO2 absorption. Leilani allegedly told her team, "We can balance the seas themselves." The invention was designed to harness the ocean's natural thermal gradients to reduce global warming effects while generating renewable energy. Leilani's design relied on the principle of ocean thermal energy conversion combined with carbon sequestration. According to her logs, by transferring warmer surface water downward and cooler deep water upward, the system could stabilize local temperatures and encourage phytoplankton blooms, which absorb carbon dioxide naturally. Engineers noted that one platform could influence miles of surrounding waters, creating a measurable drop in surface CO2 concentrations. The technology promised a twofold benefit: climate stabilization and energy production from the ocean's temperature differential. The project reportedly attracted international scientific curiosity. Delegates from Pacific research institutes visited the site, some in awe of the platform's silent operation. A visiting climatologist allegedly said, "It's as if the ocean itself has become a thermostat." Initial results suggested that, if deployed across multiple oceanic regions, the system could meaningfully slow sea temperature rise and enhance natural carbon capture. However, reports indicate rapid suppression followed. Leilani's funding was allegedly cut after pressure from energy and shipping industries concerned about disruptions. The platform was dismantled under obscure regulations, and the research team was forbidden to publish their findings. No investigation was pursued, leaving only anecdotal evidence and partial schematics in private hands. Witnesses recall the frustration and silence imposed on scientists who had hoped to scale the technology globally. Fragments of Leilani's design resurfaced decades later, prompting renewed interest in ocean-based climate interventions. To this day, no operational thermal stabilizers exist on the scale her work suggested, despite modern climate urgency. Experts reviewing the surviving plans describe them as ahead of their time, offering a method to regulate ocean's temperature and carbon absorption simultaneously. If the ocean thermal energy stabilizer truly worked, it would have transformed vast portions of the planet into active climate regulators. And if that level of control threatened existing energy and industrial power structures, it is clear why the invention was quietly erased. The enduring question remains: how many ocean-based solutions capable of reversing climate change have been suppressed before the world even knew they existed? These inventions, scattered across decades and continents, do not form a random collection of curiosities. Each represents a deliberate attempt to confront climate change with ingenuity that mainstream channels never embraced. A chilling model emerges from the shadows: ideas harvested, tested, and then quietly erased from public record. The ocean algae carbon harvester and the ocean thermal energy stabilizer were not hoaxes. Their suppression illustrates a systematic eraser at work, a mechanism ensuring that potentially world-altering technologies remained hidden from the masses. Each case points to a methodical resistance to change. From the algae farms of Newfoundland to Leilani's Hawaiian platform, efforts that could have reversed atmospheric and oceanic carbon trends were obstructed. Item 1 and Item 10 exemplify a broader pattern. Projects capable of large-scale impact faced bureaucratic hurdles, sudden funding cuts, and outright dismantling. The control exerted over these discoveries shows a network of influence ensuring that transformative solutions never left the drawing board or laboratory. The destruction was never loud. It came in silence. Patents seized, funding revoked, laboratories shut down by unexplained regulations, and blueprints quietly buried in private archives. A future where cities could self-purify their air, where oceans became active climate stabilizers, where atmospheric CO2 could be scrubbed efficiently, and where algae could reverse decades of carbon accumulation, all of this potential was systematically erased. We lost decades of environmental solutions that might have shifted the trajectory of climate change. These were not simply ideas. They were turning points, and someone somewhere chose to turn away. The erasure continues. Whistleblowers disappear or are silenced, patents remain inaccessible, and new projects are stalled under the guise of feasibility or safety concerns. Across continents, innovative designs capable of altering the global climate are quietly shelved, leaving humanity to confront an accelerating crisis without tools that once existed. Every recovered schematic or testimonial underscores a sobering reality. The technologies were functional, visionary, and deliberately withheld. The tragedy is not that these technologies failed. The tragedy is that they worked, and that was the problem. If this video was eye-opening for you, you've just glimpsed the hidden patterns of technological suppression. Over decades, inventions capable of reversing climate change were quietly erased, leaving humanity to struggle with problems that might have already had solutions. Recognizing these patterns is crucial. Awareness is the first step toward demanding accountability and ensuring that innovation is no longer buried by powerful interests. If this video resonated, take action. Subscribe to the channel to follow every uncovered story, and turn on notifications so you never miss an episode exposing suppressed technologies. Share your theories in the comments below and spark conversations that challenge the official narrative. Spread this information to friends and communities, and check the description for all sources referenced. Every link is a piece of the hidden history waiting to be explored.